This is Sai Vignan Malayala. So today we'll be going to discuss on the topic of LDA or Latent Dirichlet Allocation. Okay, so yeah, so LDA is a concept of under NLP. Uh, so what it does is it's basically topic modeling. So suppose you're in any sales organization, suppose, and you're a sales consultant, and you'll be getting millions of mails, monthly, daily, right? And there'll be different mails, like some will be promotional mails, some will be project based mails, some will be just spam mails, some will be leave mails, some will be new client onboarding mails, some will be client appreciation mails, some will be just campaign mails, right? So there are a lot of different kinds of mails you'll be getting. So suppose if there are 5 mails, you could open them and directly see what actually they are, or you can just categorize them, right? But if there are 1 million mails, then how do you categorize them? Do you is it like you want to open every mail and categorize them manually? 1 million. How much time does it take to categorize this many mails? So that is where kind of a scenario LDA topic modeling can be exposed, by which LDA can find the topics in your mails and categorize them based on its understanding. Okay, I hope now you have understood what is LDA. I give you a bunch of articles, and even without reading those articles, LDA can help you to categorize these articles and saying that this article belongs to this article belongs to this, and there are this number of topics in the articles. Suppose I give you 1 million documents, LDA can help you say that these documents are kind of pharmaceutical documents, legal documents, or telecom documents, or or industry specific documents, or leave documents, or banking documents, based on the topics or the words it has in the document. Suppose most words in document are finance, banking, banking sector, credits, loans, and all. By default, you can say that based on the words that article has, it is in accordance to the domain of finance. If the article is having words like lot of marketing, campaigns, appointments, calls, sales, then by default you could say all these documents are talking about sales. And if there are documents which are saying like words like sections, ads, legal, notices, stamps, and all, so then by default you could say by these words that these articles belong to legal documents. All right. So that is how, without even reading, you can understand a corpus of text. That's how LDA can help you with. Okay. Right. So I will be using Gensim. There's a good Python library called Gensim, which helps you to do topic modeling. Okay, and the input for the LDA is just very simple. It's just document term matrix to start with. Okay, we will be using document term matrix to start with, where uh, it is a document term matrix is just a bag of words, or different terms in the corpus with respect to their counts. That is what is document term matrix, and the inputs can be document term matrix and the number of topics. Suppose I give you 100 documents. How many topics you want to classify this into or cluster this into? So if I say I just want to cluster into two, it will try to identify two topics. If I say I want to cluster them into 10, it will try to cluster into 10 topics. Okay. And the third input can be iterations. So the inputs I'll write is document term matrix, which is bag of words like term and its count. And the second input can be number of topics. So if you want number of not 2 topics, so it will try to cluster into 2 topics. If you say 10, it will try to cluster into 10 topics based on the words it has. Okay. And the third input is iterations. So because it's an unsupervised method where it has to learn again and again, seeing the documents again and again, so you need to mention it. How many iterations should I perform? 10, 20 or something. Okay, and based on 10 times it is learning, it will try to improve and give you the good cluster. Okay, so that is how you can give the input. And so in short, I can say LDA does. How does it work? Fine. How does it work? Yeah. So I could say it's a combination like it is trying to learn. It's trying to learn something like topic mix in each document and word mix in each topic. Okay. So it is like topic mix in each document and word mix in each topic. So that is the phenomena or the goal, how it works. Okay, so how is the process? What is the process it starts with? If I start with, so firstly you need to specify number of topics. If I give you some 100 documents, then if you want to find what kind of documents they are clustered into, then you need to say there are 100 documents, so just give I want to cluster into 2 topics. So there are only 2 contents, maybe financial and marketing, so I want to just cluster these documents into 2 topics, financial and marketing. Okay, so the financial will have words like banking, loan, interest, finance, all these words. And marketing will have words like sales or market, brand, campaign, calls, appointments, right? The mains will have all these things for marketing, right? All these things. Yeah. So there are 2 topics, suppose. See, topics will not be mentioned by automatically by LDA. We need to identify the name of it. We are just considering the examples finance and marketing. And so now what it does, when you specify the input k equal to 2, I want to cluster into 2 topics. So then what LDA does, it randomly assigns each word in each document to 2 topics. These 2 topics. It will not see whether it's a right topic or not. It will first randomly assign. Open the article, first word, first topic, second word, second topic, random. Okay, randomly assign each word in each document to 2 topics. It is just assigning, it is not validating it. Okay. Secondly, after assigning it, now it again go throughs every word and its topic. It has already assigned word, right? Suppose a document has word like the, banking and all, so the is associated with the something, sales associated with something, banking associated with something. So suppose banking is associated with marketing in the first random assignment. So it will go through every word in the document, and uh, its topic. So marketing topic is finance if it is randomly assigned, and it will check you know uh, how often this topic occurs in this document. So how often this topic, the topic called marketing, occurs in the first document, firstly. And second thing it does is how often this word occurs in the topic. Suppose finance is the word topic, and the word is banking. So it will first check how often the word banking occurs in first document or the current document, and then it checks how often the word banking is occurring in topic called finance. So if it is occurring most number of times, banking is lot number of times coming in the no document in the finance, then it will say banking is related to finance. Okay. So this is how it will iterate again and again, and improve on its topics and words associated with the topic. Okay. So what to summarize what it does? Firstly, it takes the input, how many iterations and how many topics you want to consider. Suppose you specify 2 topics, then it randomly assigns each word in the document to 2 topics, and then next it goes through every word and its topic assigned in each document. Okay, it goes through every word and its topic assigned in each document, and it checks how often a particular topic occurs in document. So if a particular word, how many times, 1 time, 2 time, how often a particular topic, finance or marketing, is occurring in a document. Okay, and then it checks how often a particular word, sales or something, is occurring in topic. Firstly it wasn't checking in document, topic in document, word in topic. So what is one? Check how often topic occurs in document, and then secondly it checks how often word occurs in topic. Okay, so initially it will be null, but adding on, iterating, it will try to improve and get accurate topic and accurate topic words. So that is how LDA works and finds you the categorizations automatically. It's just like trying to learn. Okay. Hope that is clear with the concept. Now we'll go with the implementation part. So I'll be using Gensim. So I'll just import Gensim. I seem to have no data currently. So what I'll do, I'll just get some data, random data, and mix it. Okay, and then I give that mixed data as an input to my LDA, and let us see if it is actually categorizing or not. Okay, fine. I'll just take import Wikipedia and then import NLTK if it may be required. So first let me take some random like Wikipedia texts. So Mona Lisa. Suppose Mona Lisa is a Wikipedia document. If you want to check Wikipedia dot uh, page of Mona Lisa, and then if I just want one more some kind of data, maybe Taj Mahal. So let's say Taj Mahal, and yeah, now COVID time, right? COVID. So I say COVID-19 pandemic, and then I say some other input. Yeah, data science. Wikipedia dot page of data science. So I got four things. Uh, okay, I don't have Wikipedia, right? Yeah, it's installing. Yeah, it has installed. It's a library Python. So now it's running. It's trying to fetch me these pages from Wikipedia. It has already done. Now let me just check the sample data science. Yeah, if I just say data science content, so I got a lot of things, in the data science content. Okay, so now I'll merge them. Okay, corpus, my corpus equal to Mona Lisa and Taj Mahal and COVID and data science. Okay, sorry, dot content. Yeah, so corpus, and just check the corpus length. That's 4. I've added 4, right? So now I got a corpus. Now let me do pre-processing, because this data obviously is Wikipedia data and it is not cleaned one. So I'll just do pre-processing. I'll just have a standard set how to pre-process in these scenarios. I'll just copy paste that and we'll do pre-processing in a minute. Okay. That format. So I'll just do pre-processing, just copying this format. So it is just like considering only words, removing all the non-words, and then A to Z spaces, and removing prefix B, single characters removing, and start single characters removing, multi spaces removing, lower casing, lemmatizing, stemmer, everything I'm doing. I'm pre-processing it. Okay, so I just got the corpus. I'm just pre-processing it. So it's running. It has run. There's an issue. What is that? Token equal to pre-process text of doc. Yeah, for doc and corpus. Yes. Okay. So I haven't used NLTK en stop, right? So I'll just get en stop, because I was removing the stop words. Yeah, NLTK dot download stop words, and NLTK dot corpus dot um, dot stop words dot words of English. So I'll just make it a set. So yeah, now it is pre-processing properly. So it's already up to date, and it is also got event stop now. So let me check pre-processed. Sorry, processed data. Maybe 0 to 100. So I got the top 100 words, which is the combination of all my corpus. So I have cleaned my data. You see, they're all clean, proper words now. Fine. Now, because I have got a corpus, I just need to just implement my LDA model now. Okay. So from gensim import corpora. Yeah. So I'll make an input dictionary of it. Corpora dot dict of processed data. This processed data, and then my input corpus will be input dict. Now what do I need to do? Obviously, when I said initially gensim, I need to input only document term matrix. So because it's currently it's just document words, I just need to convert this to BOW or document term matrix. I mean back of words. So doc to bow. So it's a simple technique to just convert a document to bow. So for every token, for each token and process it data. Okay. Yeah, it's done. So if I just print, I'll just see. So you got my BOW, right? So first first token, the occurrence is 1, second token occurrence is 2, third token occurrence is twice. So I'm just printing top 10 to just see top 10 since it's in order, not by frequency. Okay. So, and if I see my input dictionary also the same thing. Yeah. Yeah. So obviously it's gensim dictionary. If you want, we can fetch it. Anyways, so now let me build a LDA model. My LDA model is gensim dot models dot LDA model dot LDA model of my input corpus name is input corpus, comma. Let me choose a number of topics as 4 because we got only 4 inputs when we got the corpus, and then the ID to word is input dictionary because these are input dictionary, right? We already mapped it. ID to word, ID to word, ID to word. 0 is what, 1 is what, 2 is what. Everything is in dictionary. If I just say input dict dot get 0, where is it? Yeah, 0 is abins. So abins has occurred one time in that way. So input dictionary is also there. And one more parameter, the iterations, the passes equal to 20 suppose. Now I'll run my LDA model. it has already run because it's a small data. Now let me check the topics. LDA model dot print topics. How many? Number of words equal to 10 for each topic. You see, there are 4 topics as we have chosen 4. So 0 topic is as top words, like top words like country, people, outbreak, health, reported, Chinese, pandemic. So it is like relating to China. I haven't specified in the start that to the model that I am giving input of corona or COVID. I am giving input of Taj Mahal or data science or my painting or something. I just took random data and mixed everything. But when I'm getting my model output, the top words it is saying country, corona, government, outbreak, reported, health. These all seem to relate into Wikipedia article of COVID-19. And these words building, marble, government, people, complex, garden, country, design, these all again are relating to more of Taj Mahal or something, right? Building, marble, Taj Mahal as marble, and painting, Leonardo, obviously Mona Lisa, and data science, statistic, design, scientist. These are all related to data science. So if you see, it has learned properly. It is trying to predict. So LDA basically works based on the probability of identification of a particular topic. So a particular document, if you give us an input, it can say the document can be 100% related to topic 1 or topic 2, or it can say it is 40% topic 1, 50% topic 2, and 10% topic 3. Okay, so that is how, based on the probability, LDA is trying to predict and print topics and relate to the similar words. Okay, this is how it is trying to work on the clustering. Okay, so if I just take what some more for T in topics, I'll just say print. Yeah, this has worked. So now if you see there's any difference, no. So I think I have printed the same. Let me do one thing. I'll just do let us do something like I'll increase the topics to 8. Let us see how many more identifications it can do. Although I took only 4 topics, let me see how many it will take now. Yeah, now it was 8 topics. So first it is like again corona, second one is like marble and all, again Taj Mahal and all, country, people, outbreak, health, Chinese. So it's again a mixture of some more. So I think, see, whenever you're deciding the number of topics, that's why you have to be very sure to specify it. Otherwise there's a lot of mix happening here. Although there is some limitation here, currently my data is very small. It is just like 4 pages of Wikipedia text, that also only the sample static content. So that's why it has just small vocabulary. Okay, if you have a large vocabulary, this understanding is more better. So that is how it will work. So suppose let me take a sample text and try to see what it is. Let me take LDA model itself. It has 4. No, pretty great architectural buildings are formed olden days. So I just want to see this text, what topic it is relating to. Suppose if you consider this as a document, what topic this is relating to. Okay, I think I'll just say pretty great structures are formed in history. So I'm just trying to say related to Taj Mahal. Okay, so this is a sample text, suppose. And now let me see what my LDA model is saying about this text, what category. Okay, so I'll follow the format. So text equal to, again, pre-process text of text, and then I need to also find the doc2bow. So input dict dot doc2bow of text. So now if I say LDA model dot get document topics for this text. Okay, yeah, it is saying this input text is more of relating to 0 in the start. So 0 is what? Painting, sorry, this one, painting learn radio, right? I just say top 20. So painting, all these things. So it is more of relating to century, picture, museum, Italian, landscape, and all. I think it is properly saying or relating to Taj Mahal only, or structure or something. So it has got proper 33% weightage. So it is proper. Okay, let me take some other text. This COVID pandemic seems dangerous, with great outbreak affecting millions. So if I say run this now, it's more of trying to again say to 0. So where it is saying, no, not 0, sorry, 84% 1. So it is more of trying to relate to country, people, outbreak, health, and all, million and all. So it seems our data has been properly structurized. My random data, which is a combination of Taj Mahal, COVID, data science, uh, hmm, and Taj Mahal, right? Yeah. So I have taken topics like Taj Mahal, Mona Lisa, pandemic, and data science. So I have merged all of them and made an LDA model, and I have classified it into 4 topics. So my 4 topics are properly identified as I see with respect to the topics it has identified, the words it has identified, and now my topics 0, 1, 2, 3, 4 has definitive words, and if I give a new text, it is trying to say what kind of nearest possible input it can be categorized to. Okay, so now if I give you a 100 million documents or 100 million mails, still you will be able to run your LDA model as I see and get the nearest email with respect to each topic. So I think that is a great lesson for today. So try to implement your own LDA model with the document matrices approach. Okay, and you can use different other ways to develop this LDA model, and there is something called LSI, which is latent semantic, semantic understanding methodology. So it doesn't only take the document term matrix, but it is more of in relation to finding or understanding the sentiments or the semantic information in the text. Okay, sometimes document term matrices don't work properly if there is semantic information in it. So understanding semantic words helps you to build a better model also sometimes. So in that case, you can go for LSA. For now, LD is a good start to understand topic modeling in NLP. It's a wonderful topic. Go ahead, guys. Good luck.
To know more, follow and subscribe to upGrad.